Good morning. Welcome to PG Department of Computer Science. I am Ms.V.Muthu Sowmiya, Assistant Professor of Computer Science, A.D.M College for Women, Autonomous, Nagapttinam. In this session, we will discuss about instructions code. Before discussing instructions code, let us define program. A program is a set of instructions that specify the operations, operands and sequence by which operations are to occur, in which the operations can be addition, subtraction, multiplications and etc. Operand can be registered operand or it can be memory operands. And sequence by which processing has to occur means the sequence of instructions to return to get a desired result. Okay, so computer instruction after program, because the program is made up of the computer instructions. So what is instructions? A computer instructions is a binary code that specify the sequence of micro operations for computer. That means, say for the example, I want to perform addition, and for performing addition, the basic operations which are required to fetch the data from memory to get the stored into the register. Then perform the additions to back a result to the memory. So such instructions micro operations are defined based on this binary code, and that is instructions. So this computer instructions are read from memory and they are transferred to the control register. In this control interprets this binary code of instructions and proceed to execute the issuing sequence of micro operations. So that means when control register will fetch the instruction from memory, at the time the memory code is specified, and this binary code will be decoded, and based on which the operations will perform and the micro operation which are going to carried about to perform it. So now let us define what is instruction code. So an instructions code is a group of bits that instruct the computer to perform a specific operation. So we can say it's nothing but is a instructions itself. But the instructions code is a group of bits inform the binary. For example, add 457 means an instructions code with address 457. So this is an instruction. So out of this add 457, add is operation code. Now what is operation code? The operation code and instructions is a group of bits that define such as operations or add, subtract, multiply, shift and complement. So orders an operation code, and 457 is an address of operand in the memory. Now this operation code are designed with unique binary codes which cannot be changed. So this code will be defined that add operations or multiply operations or shift operations or any. So that's why the name given us opcode. The number of bits required for operation code of an instructions depends on the total number of operations available in the computer. That means, for example, if we are having 16 operations in the computer, that means 16 of codes available into the computer. Then this opcode number of should be 4 because 16. Okay, so to rise to 4 is 16. So number of allocated to opcode is 4, and the operations code must follow the relation. That is, it should be at least n bits for given to rise to n operations, or it can be less on also, because the definition define some distinct operations. Now these are about programs, instructions or output. Now let us see they are organized into the memory. I say for the example, for a general design of a computer, we would be taking memory size of 4096 cross 16. That means the memory contains 4096 words of 16-bit each. So this memory is logically divided into many parts. But in our system, we are considering 2 parts. First is instructions and second is operand, on which these instructions are going to be executed. So this instructions for consist of 16-bit. How many? Because the word size of memory we are treating to be like a 16-bit word size. So this instruction size would be like taking it to be 16-bit instruction size. Along with is require one or more register termed as a processor register, because the basic computer, so we require processor register, which is when name it to be a AC. AC means accumulator, which is accumulator is a result, or which is accumulates the operands, or which accumulates the data fetched from the memory. So this instructions are now discussing in instruction in detail. This instructions should have some format was discussed in 16 bits. So these 16-bit are divided in two parts. One is 0 to 11, that is address, and the rest part is 12 to 15 is opcode. So 12 address located to address and 4 to or allocated to opcode. So questions are raised to 12 are allocated to the address, because the number of words memory were defined to 4096. So is it to rise to 12, as it is to rise to 12. So 2 point each the memory locations we are required 12 bits. So we can point to 4096 locations of the memory. So that is what term it to be the instruction format. So now let's talk about operand. Now what operand to be operand size of size, obviously it should be 16-bit, so 0 to 15, because this is no division of division is the operand and 16 bits. So this is what is the stored program organizations in the memory. Now let's discuss instructions format in detail. So instructions format, as we discussed, divided in two parts. One is address and another one is opcode. So 0 to 11, 12 bits for address and rest bit for opcode. But again, this opcode we are dividing in two parts. The 12 to 14 bit or opcode and 15 bit, that is what we term into be. One is the bit. Now I stands for direct, indirect. So consider this to be the instructions, a binary code. We don't know what is mentioned, but see, we are having this code. So out of the 16 bit, this is a 0 to 11 or address. Then this 3 bits or opcode, and this most significant bit, that is 16 bit of is I bit. So this is the instructions add 457. Now you can see the opcode 001 for add, and for 5/7 of binary, for then binary file, and this is the binary 7. So this is the instructions. Now let us discuss this I in detail. Okay. So direct and indirect addressing. What is direct addressing? In the second part of instructions, we define the operand by mean of address. Now that address stored in the operand indirectly. Then it is direct addressing, but if the second part of instructions contains the address of some memory word in which the address of operands is stored. So it is indirect address of address, that is called indirect address. Let us see visually. Suppose this is the our memory. In this this is instructions is a written val 0 bit set of I, or out of opcode as 457. Now the memory locations we are defining is to be 22 at 457. We are having a operand available. So direct addressing, or what will be happening is this operand would be fetched and added to the accumulator, and result will be stored back to accumulator. So this is the direct addressing. Now let's see indirect addressing. In this indirect addressing, let's say now I am setting as I bit to be one, that means it mentioned that it's indirect addressing. Add as code, and 300 is the address provider. But now at 300 we don't have the operand directly, but at this 300 we are having some address, that is 1350. So at this 300 we are having some address 1350 and this is 1350 stores the operand. So this operand would be fetched, would be added in accumulator and result would be stored back to the accumulator. So this how direct and indirect addressing of memory bit. That is called indirect addressing. So let's see the type of instructions. The basic computer has three 16-bit instructions code format. First one is memory reference instructions and second one is register reference instructions and third one is input output instructions. So let's see the topic is one by one. In memory reference instructions, first 12-bit or 0 to 11 specify an address. Next 3-bit specify operation code. Leftmost bit specify the addressing mode. I equal to 0 for direct address and I equal to 1 for indirect address. In memory reference instructions, the address field denoted by 3 hexadecimal notations and equal to 12-bit of address. The last mode bit of instructions represented by symbol I. When I equal to 0, the last 4 bit of and instructions have a hexadecimal digit equivalent from 0 to 6 since the last bit of is 0. When I equal to 1, the last 4 bit instructions have a hexadecimal digit equivalent from A to E since the last bit in 1 and the memory reference instructions format for your kind reference. Then next type is register reference instructions. In register reference instructions is the first 12 bits specified registered operands. Then the next 3 bits equal to 11 specified opcode. Therefore, left 4 bit are always 0, 1, 1, 1, which is equal to hexadecimal 7. This is the register reference instructions format for kind reference. The last one is IO reference instructions. The 12 bits specify the IO operation. Then the next 3 bits equal to 1, 1, 1 specify opcode. The last mode bit of instructions is a 1. Therefore, leftmost 4 bits are always 1, 1, 1, which is equal to hexadecimal F. This is the IO reference and the instructions format for your kind reference. I think it will be clear to you, and thank you to one and all.